Hello everyone, welcome to Practical GCP. So a super exciting topic today on the continuous query topic. Google has just released in public review. Quite a lot of you are talking about on LinkedIn. I thought I'm going to do a deep dive on how you can potentially use it to save 50% of your data engineering effort. No joke, right? So we have a quite packed agenda. So let's crack on and go through these topics in detail. So cover what the continuous query is and dive a little bit into the details of how it actually works. And I'll give you some examples, especially with the diagrams. There's not a lot of text in this video to show you how you can potentially save 50% of the data engineering efforts, right? This is development work, maintenance, all of that stuff. Of course, I'll do a demo so you can see what it looks like in action. I do, however, found a number of issues, and these are particularly to do with concerns on the concurrency of how many continuous queries you can submit and the cost associated with it. There's a bunch of features I would really love for this to be released, potentially in the near future in GA for more mission critical pipelines to make this a lot easier to manage. And finally, I'll cover some of these considerations I think you need to think about in order to run this on production, with a few potential next steps on the next few videos I'll release on continuous queries to cover different topics on this thing, because it's quite a big thing. The continuous query, in my view, can fundamentally change how data engineering work in a lot of the area we do on a daily basis. So what is continuous queries? So in here, what I've done is this is a representation, right, of a single table and a single record of a fake customer record, right? So you can see, if you look from the top to bottom, assume this is a BigQuery table. You have a customer with the ID 1001, right? This customer, when you ingest the data from your source system, initially you would be inserting that into this BigQuery table as a row, right? And then you might make a series of changes. So this update is representing a change on the phone number, followed by another update that changes the customer address, right? And finally, when the customer wants to leave the company or wants their record erased, so they may submit a GDPR request called right to be forgotten. So you might have to erase, and in this case, you have to erase their record in this case. So all of the customer details are now obfuscated, right? So then in this particular case, you would have done 4 actions to this single customer record, 1 insertion, 3 updates, right? So what continuous query does is once you have it deployed, it runs 24/7, right? It's like a job. It's not a query that would run it and finish. It doesn't finish. It never finish. It listens to all of these changes as they happen in real time. Then what you can do is 2 separate things, right? You can write it to another table, right? So every time when this happens, you can write it to another table about those changes. So then your data can be inserted into a downstream table, then you can chain it with another query that can either be a continuous query or a normal query, right? Or you can do the reverse ETL part, which is the most powerful thing of what continuous query provide. For whenever these changes happens, you can basically track those changes and export them into various systems, right? Outside of the BigQuery ecosystem. This is where it gets really, really powerful. I'll show you more details later on with a diagram of what kind of designs you can use this to adopt, and then how some of the things you've been doing before versus what you can use continuous query for. And that's where the 50% effort saving would come from, right? I think it's always worth to dive a little bit into thinking about why this is actually possible, right? If you think about this feature called time travel, I'm sure all of you would have used it before. BigQuery allows you to, if you think about these blocks are things that are immutable in the storage engine, right? Then you can keep appending every time you do a change into the record, you load some new data. BigQuery doesn't actually update on the storage engine. What it does is an immutable thing. Think it as it keeps appending little blocks, right, from the left to the right in this particular case. And then this is time, right, from the left to the right. So as you start adding more data or making changes to your tables, these blocks kind of started stacking from you can get more and more of these blocks. Time travel is something utilizes this feature that you can basically go to any point in time in the past, within the last 7 days, right? This is, if I remember correctly, is even accurate to microseconds, right? You can go to any point and you say, look, I want to see exactly what my table looked like yesterday at 6 p.m., 1 minute, 10 seconds, whatever, right? So then you can see the version of what you had in there. This is the key that how the continuous query can work. Because of this storage engine you see it's almost like a message queue with a bunch of events, right? It just gets queued up, and then you can actually track all of these activities, these changes. So this is I put in an illustration of my understanding of how this works, right? So think about this append-only blocks like a message queue. So on the right-hand side is the first in, right? So the first one message comes in, and then you have number 1, 2, 3, 4, all the way to 20 in this case. Then in this case, you've had 20 activities, right? Done to, let's say if you assume that customer record, you could have done 1 append and 19 updates in this case, right? To that record. So they could be, let's say, if you just think about it as one record to keep it straightforward, to keep it simple. Then think this as like a message queue, like a PubSub message queue, right? So you produce the data, the changes or the append, all of the stuff that happens on a BigQuery table is like you're producing to the message queue, right? In the right order. And then it's easier to understand, what is actually happening here. You literally like have a subscriber in PubSub. You subscribe to all of the activities that is happening on the BigQuery table at the storage layer. Then you can do something about it, right? That's something, basically the things I described earlier in this deck is you can save it, the activity, the changes to another table, or you can do the reverse ETLPs and send it to another systems. But the key is you're actually listening to all of the activities that are happening at the storage layer natively to BigQuery. So you can subscribe and then send it to do something about it and then send it to another place, right? This is where the most powerful thing is. So it's not like you actually running a query in batch. This whole thing is like a message queue, subscriber, listener to track exactly everything that happens at a single activity level in a single BigQuery table via SQL. Right, so where is this 50%? Where did I come up with that number, right? So if you think about what data engineers do these days, a lot of the time you would be, let's say you have source systems, right, from the left. You could have CDC change data capturing solutions that bring the source data in real time or near real time into your BigQuery tables. You could also have the analytics engineering teams that runs DBT jobs, right? So those are batch, either daily or hourly or probably 15 minutes. When they finish those workload, they would typically save this data in a BigQuery table as well, right? Or you could have more complex use cases where you can create audiences. You can, as part of your data science workload, you could create something you could do something a lot more complex, but at the end of the day, you still produce some data, some audience, or some features that you put into a BigQuery table. So that destination is always BigQuery. So this is the problem, right? So right now, without continuous queries, what we typically have to do is to deploy some sort of solutions to track the changes in those BigQuery tables and then send it to different places. Those different places are really critical. Why? Because you can see in this case, it typically serves application traffic for your consumers, right? You could have PubSub message queues that you need to get some data out of BigQuery so that you can use Cloud Run to subscribe to those events. Then you can send it to other storage engines such as Datastore because you might have applications needing a document database, or you might need to send those data to third parties via near real time, right? So, or even real time. But it's really hard to do if you try to do that in a batch way. And there's no easy way that you can do this in real time at all, right? So there's other use cases you can see. There's a spanner I put in there as well, which, sometimes because spanner is a very powerful database. It's not just something you can use it just for transactional database. Very often you could get data out back reverse that into the Cloud Spanner database. Then you can also serve applications. So you can see all of these use cases require you to somehow use some sort of Delta tracking batch job. So in here, I put in Cloud Scheduler, Cloud Run jobs, or you can have your Kubernetes jobs. You can have many other stuff, integrators. It is very complex and it's very time consuming. You typically have to look into Delta tracking, offset tracking, how to do the scheduling. You need to write Python as well. Keep in mind, continuous query is SQL. And then you have to deploy some services, right? So these things you have to manage, and it's not actually that straightforward. And when you have a lot of them, it's quite difficult to track, right? So you have to kind of make sure all of them works correctly, deployed correctly. It can get quite tricky. So this is where continuous query comes in, right? When I say 50%, it could be more, it could be less, but it's significant. Because right now, what you do is you literally just listen to those tables. So keep in mind, it's not just for something that if the upstream is real time, this is useful. It is useful for anything, right? Anything in the upstream. It could be Teams, it could be a CDC source system, it could be anything, right? So it could be batch as well. And then you literally deploy continuous queries to listen to, let's say, even a DBT, a team runs DBT, then generated some audience, right? You can listen to those things, and even they're batch, but why do you care? Because every hour you get the changes flushed into your continuous queries listener, and then you flush into your downstream. One of the key things that continuous queries does is it has the integration with many other Google services. So PubSub is the most powerful one because from PubSub, you can easily get this connected into Cloud Run and then do whatever you like with it, right? So this is the bit that usually you have to deploy some, Delta Run jobs and trackers, all of that stuff. Now it's just a listener and it goes into PubSub natively. It also has the direct integration with BigQuery, with Bigtable. And I believe it also has a Cloud Spanner sync, which I saw the documentation, but I couldn't find it again. But I'm pretty sure that one is in there as well, right? So I think the direction this is going is Google is most likely going to just keep adding different connectors to all sorts of different things. So you don't really have to manage the ETL things at all. But keep in mind that even you have the tools, right? You have the tools right now. If you buy third-party tools, all of the different things, you need the native listener capability of continuous queries to be able to stream data out of BigQuery in real time. And this is something that we never had before. And that's the killer thing, right? So it's not just about saving 50% of your effort. It is also turning something into mini batches or batch jobs that you have to use scheduler to trigger or run into something that is from the time when the data is written to the BigQuery table that where you're listening to that, from that time onwards, everything is real time, right? This is the key feature here that is a native at a storage engine layer of BigQuery, not some kind of batch job. So that's the fundamental difference, making this not just a very powerful time-saving thing, but also give you this really strong capability to stream data out of BigQuery into all of your operations or all of your use cases that you can unlock value to your customers using continuous queries. Right. It's always good to see this in action, so I'm gonna finally got access to the public review. So I will show you how this works, right? So first of all, in order to use it, you need to reserve some reservations. So there's a few things you need to understand here, right? So I'm pretty sure I understood this correctly. So you need to use the Enterprise Edition, not the Standard Edition when you reserve the slots. So first of all, you need to understand this the continuous queries, you must use it with slots, right? You must have a reservation. You have reserve some slots, and you can use continuous queries. It does not work with on demand, right? This is very important to understand. So when you reserve some slots, you can reserve, I believe, a minimum of 50 slots, right? I'll explain some of the differences when you actually started reserving very, very low slots, and then how much it's going to cost later on as well. But let's say you reserve, in this case, I reserved 100 slots. One key thing in here is you must have a baseline. Continuous query does not support auto scaling. In the future, it might, but I hope it does, because there's something I need to explain later on as well, which there's some of these things I'm quite concerned about the cost. But if you put the reservation in, you must have base slots. So the minimum 50, 100 is normally the number you could go to get started, right? So what this means, you need to be very aware of the cost in here, right? 100 slots is not cheap if you run it 24/7, and this is something you do have to run 24/7, because it is a query you submit and then continuously run. It doesn't stop. So this job, as soon as you submit, is going to run 24/7. So you can see in the continuous query reservation, I put in the max size and baseline slots as exactly the same. And also in terms of concurrency, you cannot set it in this case. For continuous queries, the concurrency, it will automatically adjust that for you, which I have a point to make later on this as well. And when you do the allocation to your project, right, this is how the same way how reservation works with normal queries, but you have to give it a continuous query. You have to assign the continuous queries to it. So in this particular case, right, for the continuous queries to work on your project. So if you don't assign it, you can't use it, right? So once you've done that, this is what it looks like. So I've got two use cases for you. One is you can use the insert into statement. So I've got some in here. I've got some dummy code to generate some fake data for a customer. You can see I've got customer ID, first name, last name, all of that stuff, right? So what I'm doing is basically just creating a schema here, right? I'm just creating a schema here, and then within this customer source table, that I basically so this job is simulating the first use case that I want to insert the result. So as soon as the data comes into the source table, let's assume this is like a CDC solution, right? From the upstream coming into your source table, and then you want to run a clean job as a continuous query to insert all of these. In this case, I've changed the naming convention of the columns, right? So let's say this is as simple as that. But you can do a lot of other things here. But this is just to show you, if you run this as continuous queries, it will listen to all of the changes or append events and all this other stuff that happens in the source table, and it will insert into the clean table in real time. So if I just submit this, right, you can see this execution starts, and then it will, once it started running, it takes about like 15 seconds, I think. You start seeing that it started giving you more information. What's interesting is you can go to the execution graph, and in here you can actually see what is happening, right? Look, so now it's running, right? So you can see if you click on the input, you can see I've got records read or records written, and I have this one as well that basically tells you all of the information of, you see you've got 40 rows in here, right? And then you have the input, records reads, record written, and it has the output. Right, you have a lot more detail, and it's got some nice animations that you can actually see. If you want to debug this stuff, this is quite useful. So now you see this thing is not finishing, right? It just runs forever, right? It just runs forever. And this means if I run this script, I can literally pump in a lot more data. I'm just going to run one iteration to put 100 in there, right? So let's say if I run this. So now this is going to pump in more data into the table. As soon as it goes into the source table, because this is where this goes, it will listen to all of those events, and it will put it into the clean table. I've done quite a lot of the testing already. So if I open this in a new tab, you can actually see in the clean table, I've got quite a lot of records already in here that has been pumped in through the continuous queries. So this is already more than 1,000. But you get the idea, right? So this is something you can do. And then now you see the naming convention of the column names has been changed and it's been pumped into this table via this continuous query. So now it's still running, right? Yes, so the other example I had in here is PubSub, right? You can see this is the slightly different syntax. You have export data, you set the options to Cloud PubSub. Then you give it the URI of the PubSub message queue topic name, right? The fully qualified name based on your project ID and the name of the topic. And then you can do things like this as well. So keep in mind, you can use CTEs to change these queries as well. It's not limited to just run a simple query. It can be actually quite complex. So in this case, I've actually wrapped the cleaning, let's say renaming of the columns into one part of the CTE, right? And then it will convert. This is what you have to do in this in order to put it into PubSub, because it only supports one column, right? In this case, it has to be one field, otherwise it doesn't work. So what this does is basically put all of the columns you need into a struct and then convert it into a JSON string, give it a name as a message in the column name. So this will then convert the whole column row by row into a JSON string. This is how it can actually be pumped into the PubSub later on, right? So if I run this, so this is continuous query as well. This is the previous one I've got. This is continuous queries. So now as it starts, the execution graph is going to be pumped in. So I should be able to see, yeah, look. So because this is basically the message coming out on the other side from the continuous query I've just started executing. This is a dummy PubSub consumer I've created, right? You can see this. All this does is to subscribe to the subscriber in the message queue. I'm looking at the query's default subscription, right? So as I started pumping in the messages from one side using the continuous queries, I get all of the messages pumping out in real time in the subscriber. So this is how powerful this thing can be. So you can think the possibility of what you can use this for is really, really vast. It's unlimited. You can do whatever you like with this stuff, which is very, very powerful. Right? So you can see this is going. And then, yeah, the execution detail is in here. You see it tells you how many records it's been doing. So the UI is actually very useful. So you can do a lot of the debugging in here as well. But as you can see, these two queries are running, right? They're running forever. They don't stop. Okay. Right. That's pretty much the two use cases. One thing I want to show you is this monitoring part. So this is under monitoring of the BigQuery section. So you see, what you can do here is to look at the slot usage of your queries and then the concurrent jobs that are currently running in your project. Right? You can see now I have got 2 continuous queries submitted and they're running 24/7, and I have a number of 2 in here. And then this is the slots, right? So how many slots this is actually using in the slots usage. So what's interesting here is this actually brings to my next point is I probably need to do a little more digging on this. Is it looks like the efficiency of continuous queries, and this is probably because it's running directly through the storage layer, is extremely efficient. So it doesn't actually use that many slots. But one thing that is interesting is that it won't allow me. I hope this is a beta limitation, not a thing that would continue. You see, I've submitted 2 queries now, right? So let's go ahead and submit a third one. So this is exactly the same query. I can pump more messages into the message queue that I have, right? So you have this one, which is going into the table. I have this one, which is the message queue, one already submitted and live. now I've submitted another one, right? So now we have 3 jobs running in the in total. So in a bit, it should tell me there's 3, right? And then let's see if I try to start a 4th one. So you see, now I'm getting this error message. So this is something I've not seen before, and this is the first time I'm looking at this, comparing to what's happening in the private review. Is now I have 100 slots reserved, right? When I tried earlier with 50 slots that reserved in the baseline, I can only submit 1 concurrent continuous query, not even 2, right? So now I've given 100, now I can submit 3. So the 4th one always fails. So I don't know what the pattern is. So I kind of started putting in a little page in here that you can see this is what I've seen, right? From my observations. 50 slots, you can only run 1 concurrent query, and then it fails on the 2nd one. For 100 slots, it can run up to 3 continuous queries, and it fails on the 4th one. Otherwise, you get this kind of message. So what concerns me is the cost here and the efficiency of how this is optimized. 50 slots is actually quite expensive, right? So it might not sound like a lot, but the cost of each slot hour is $0.06 in this case in the US region, multi-regional region, right? So you have 50 slots and it times 24. The issue here is because you have continuous queries running all the time, so it doesn't support auto scaling, and this means for all of your slots, you have to put all of these as baseline. So my 50 or my 100, they are in baseline, which means it would charge you 24/7, and that is very expensive. So if you look at even 50 slots, it can cost you more than $2,000 per month, and then 100, it would cost you almost $5,000 per month. And if this only allows you to run 3 concurrent continuous queries, I do not believe this is usable at all. The entry of the bar is too high, right? So I hope this is a public review limitation, not something that cannot be fixed, because otherwise I do not believe 3 concurrent queries is anywhere near enough for any team to run. You would have easily 10 or even if not more, because this is very, very easy now with SQL, right? So people will do a lot more deployments. 3 for 100 slots as a limit is very unreasonable in my view, right? So, and the things I don't understand is if you look at the slots usage here, so this is what I had earlier with all the 3 jobs concurrently running, it only uses 4.78 slots, right? Between all of the continuous queries jobs combined. So, and I tried to send thousands of messages per second into this thing as well, and it's actually very efficient. It doesn't actually use more slots. So my question here is, how about my 95 slots? Are they just get lost? Sure, you can use this for other things as well. Probably for normal queries. I don't know if it actually shares the pool, but this doesn't make a lot of sense, right? So you can't just use 5 slots because it's efficient, and then what about my 95 slots, and it charges me everything and restrict only 3 concurrent queries for 100 slots. So something doesn't add up. So this is something I need to check with Google to see exactly what the thinking here is, because if the bar of entry is this high and then you can only deploy 3 queries, I do not believe this is going to work, right? From the cost perspective. Right. There's a number of features I really love to have for mission critical pipelines. So one thing you probably noticed is you do not have the ability. So if you look at these queries I've submitted, there is no way you can just deploy another query, right? So it's not like, if you think about Cloud Run job or Dataflow jobs, you can always deploy onto the existing job, right? You deploy on top of it, and it runs, and you don't lose anything. It manages all of the offsets, right, for you. The problem with this is if you have to kill it, I'm just going to kill all of them because I don't need them anymore. If you kill them, then it stops, right? So the default behavior is every time you start your job, it will start from the scratch. So you actually load all of your tables data and then, pump into the next one. that's okay for small tables, but if it's a very big table, then it can be very problematic on the volume, on the size of the data they process. There is a way I'll cover later on that you can use a append syntax to actually decide where you want the offset to start based on the timestamp. But the issue here is that it would be ideal if you can just redeploy on top of the existing ones, and then Google will manage the offset, right? So that would be a lot easier, just like the other services. That's something I think this is going to be extremely useful to save a lot of people's time on trying to develop their customer solution to track offset, right? A dedicated GUI to look at all the running and failed jobs with status of each job. So currently the way you do this, right, is let me just submit one, because then I can show you where to find these things. Under job history, if you go to project history, you can go status running, right? So same as your normal queries, but it doesn't really differentiate continuous queries and normal queries, and you have to do a lot of fiddling around to actually find them. So because it's mixed up with all of the other queries. And at the same time, there's no easy way you can just cancel it, or you do stuff with it. You always have to, let's say, if you show job details, you don't really see much. It's just the details in here, right? If you view job in editor, then it's going to pop up in here, which you can cancel the query. I guess at the end of the day, you probably wouldn't want to deploy anything in the UI anyways, so you would use other mechanisms. I'm hoping there's a Python SDK. I need to look into that to deploy this from in the background, that to manage these continuous queries. But if you want to look at them, you kind of have to take quite a few steps to find them. So because continuous queries are not ordinary normal queries, they have features, there's things you can do about them. It's quite different, and they run all the time. So it feels a bit like it doesn't really fit into this place. It almost feels like it should be somewhere else in its dedicated place, just like, like a Cloud Run job, right? It's its own thing, quite different to the other queries. But that's just my view. Right. The other thing is what I really hope for is some kind of GUI to track all of the historical versions and doing rollbacks, just like Cloud Run. Cloud Run's rollback from the UI, from the GUI, is actually one of the things I like the most, because if you have on-call situations, you need to see what happened before in the previous versions, you can just roll back very quickly from the GUI, right? This is a very, very powerful feature. But obviously with this one, you have to cancel a job, you have to redeploy a job. It is quite tricky to actually manage things like rollback for a production workload. If you made a mistake, you want to just go back to the previous one, it's quite tricky. You have to do this on a version control level, you have to cancel it. So you have to do quite a few things to make that work, right? And then the GUI to track delayed and back pressure. So this is one of the things I can't really see easily. So let's say if you have a very large table, the initial run, you have, let's say, 1 billion records that you need to flush into a message queue on the other side, right? And that's going to take some time. So I don't remember finding anything that let me track that sort of things on the delays and back pressure. So I don't know how much it's actually doing and how much is left. There are something in the, if you look at the thing in the execution graph, I think there's something in there. Not sure what's going on here. Oh yes, execution graph. You can see this thing, but it doesn't seem to tell me where it's getting on. So there's no easy way that you can actually just visualize, how far it's going, that kind of stuff. So I think that would be quite beneficial if you have something like that, like you can, as for debugging, for tracking. And last not least, I really think it needs much better utilization for the slots with concurrency. For 100 slots, you only allowed to submit 3 jobs is too expensive. I do not believe most businesses would actually be happy to use this because it doesn't scale, right, to enough jobs. Especially, I don't understand it if you only use 3 or 4 slots. How about the remaining 95, right? It doesn't make a lot of sense. Hopefully, it's just optimization issue, not a limitation. So the other considerations to run on production. So this is reiterate the point I mentioned earlier on the append syntax. If you look at the bottom left, right, in this thing, that you could use a syntax called append to the table to start from a start date and an end date. You can actually adjust, because think about that example I gave you about time travel again. This is very, very similar stuff, right? So you can use this to only backfill a certain time period, or just typically you put a start time, right? This is particularly useful for production workload. The first time you deploy, you wouldn't put a date in, right? But the second time you deploy, you need to know, okay, where did I get to? And then you're going to put that date in, and then you're going to supply that. So it doesn't have to go back to all the way to the beginning. Especially if you have a large table, this could cause a lot of back pressure to downstream system as well. It depends on the latency of the downstream system. So be very, very careful with that. However, having said that, this is not that straightforward to set up. The documentation has given some examples using information schemas, but I'm not sure how reliable those things are. If you have any delays, are you going to lose any data? But the key thing in here is you cannot lose any data. You must track your own offset. So this is something I'm not going to cover in this video, but the next one I'll show you exactly how this can work on a production deployment. Okay, on the next steps, one thing is not going to include in this video, but I will be showcasing how to deploy this to production with the offset tracking. I think that's one of the key things that we need to be sure that you have options to, let's say, start from the very beginning, just like a message queue, right? If you do want to do backfill or do you not want to do backfill, how do you make sure if you actually redeploy something, after canceling the continuous query, you do not lose data and you do not process more data than expected, and how to keep the pipeline idempotent to make sure that all of the downstream systems does not become inconsistent. The other thing I wanted to also talk about in a different video is about non-SQL workload. Because very often when you run your existing workload in the data engineering pipelines, you might have to do a lookup, right? You might have to do a lookup to another storage engine to enrich your data. That data might not be in BigQuery at all. So it depends on the things you need to do in there. You may need to invoke certain things that requires the Python workload or requires API calls and other things. I've got an idea I'm working out in my mind at the moment, and once I work it out, I'll show you how to handle those use cases as well in a separate video. So minimum 2 more videos I'll create on this topic, but for today, this is probably more than enough already, right? And that's everything I have for today. Very important and powerful service of continuous queries. Well done, Google, on that. I do have to reiterate on the point on the error message I'm getting for even with 100 slots, I can only submit 3. Hopefully that's just something wrong with my project on the submission, not a continuous queries limitation in any way. But yeah, it does feel something isn't quite adding up in the, giving the amount of slots is actually used, which is very, very minimum. But it's not actually giving us ability to deploy more continuous queries in the same project, which I do not believe is going to work well, considering the cost that is the 24/7 cost of all of those fully committed slots. Right, so yeah, that's the end of this video. I think I will leave it there. Thank you very much for listening. See you next time.
Go out!